Hi everyone, Miss Spung here, starting chapter 12 for geometry, where we are going to learn all about surface area and volume of what we'll call solids, which are like 3D figures. So here on this first page, you can see a bunch of different diagrams of solids, and you can also see something that we'll be working with a bunch today, which are nets of the solids. So for example, here's a cube. And then here is that cube's net is what we'll call this, which is basically all of the sides of our cube kind of unfolded. In the diagrams on the bottom here, you can see that we've got nets of all of these different types of figures. We're not doing anything quite as complicated as several of these right now, but we'll get into that as we sort of keep going. And I have an animation later on to show about sort of how some of these figures can be unfolded into their nets. Okay, so today's focus is going to be on surface area of specifically prisms and cylinders. So we'll be finding the lateral area and the surface area of those things. You can see that there will be some vocab, so my recommendation when we get to that vocab is to probably pause the video and make sure you've got that stuff added into your own notes. Okay, let's get started. And we're going to start with the vocab associated with our prisms. So the first thing to know about a prism, it is going to be made up of two parallel and congruent polygons. We're going to call those the bases. So we've got our bases here drawn. Let me maybe sketch where that is. In this case, we have a hexagonal prism, which tells us that the bases are both hexagons. Same down below. We'll talk about how this is actually a slightly different type of prism. There's our bases. Now, the base edges then are going to be, of course, the edges of those bases, as it sounds. So basically, the sides of the bases. I'm not going to necessarily draw on all of them, but you can see that's where our base edges will be. Okay, so the other sides then that make up our prism, those are going to be called lateral faces. And those are going to be any faces that are not the bases. Those are always going to be parallelograms. I kind of skipped over that from up above. The base edges are connected via parallelograms. So all of these sort of rectangles as they appear here, sorry about the passing siren. All of these, and in fact these here, these are all going to be my lateral faces. And of course the lateral faces have lateral edges. Let's see, there's our lateral edges. Okay, so those connect, of course, our bases. Now each of our prisms are also going to have a height. And the height is determined by the segment that we refer to as the altitude, just like when we were talking about finding the area of various polygons. So the altitude is going to be some segment that is perpendicular to the base. So we can see here in our right prism that we have altitudes actually anywhere we have lateral edges. Because we have this 90-degree angle, we can see that our bases are in fact perpendicular to the lateral edges, or to the lateral faces. Now in an oblique prism, that's specifically then not a right prism, anything that's not right, so it's kind of like slanted like we see here, then our altitude is some segment outside or inside the prism, or outside of the prism, that again has to be perpendicular to the bases. So the length of that altitude is of course going to be called our height. And we'll use that height, the measure of that segment, when we talk about the area, talk about the volume, and all that good stuff. Okay, so let's look at how we find the lateral area of prisms. Okay, so the lateral area, we'll often call that L. that is going to be defined as the sum of the areas of the lateral faces. So it's kind of like the surface area except for the bases. We're not counting the bases. So here I've got a triangular prism. That term tells me that the bases of this prism are triangles. We can see that, I think, pretty clearly here. And I'm given these dimensions of A, B, and C, along with my height, of course, for the various sort of sides of my triangle. So if I'm just looking at perhaps the base of this triangle, I've got A, B, and C, just in case that wasn't clear. Now I also have drawn a 2D net, so what it kind of looks like when I unfold this prism. So I have my two triangular bases, but then you can see my lateral faces are all rectangles of some kind. And the rectangles all have our dimensions A, B, and C, and then they all share the same height. So we're going to think about how that turns into kind of a formula for our lateral area. But first I just want to show a little video here about sort of demonstrating how these nets work. Let's see if this actually works. Oh no. Okay, maybe I'll end up linking that video on the same page where this video will be linked in the calendar. Sorry about that. Okay, let's jump into the area of our prisms. So as you can see here, the line that showed up here, the lateral area is going to be equal to A times H, that's the area of this first base, A times H, plus B times H. If I can make that a different color, that would be helpful. B times H is the area of the next lateral face. And then C times H, which would be the area of the final lateral face. So the sum of the areas of our lateral faces. But we can actually simplify this a little bit. Notice that H is a common factor amongst all of those separate terms. So I can kind of factor that out. So I can rewrite this as A plus B plus C times H. Well, A plus B plus C, that actually is like my perimeter of my base. So I could write this instead as perimeter, P for perimeter, times whatever my height is, P times H. So in general, this is going to be the lateral area formula for a prism. We've got that up here on the next page. So the lateral area of a prism, of course, feel free to pause if you want to write this entire thing down, but ultimately, of course, this is the important takeaway. So maybe let's give that a little bit of practice here. So we're going to find the lateral area of this regular hexagonal prism. So again, the term here, hexagonal prism, that tells us the base is a hexagon. So keep an eye out for the terms we're working with, because that will reveal a lot about what we're doing. Now we're finding the lateral area, not the whole surface area. So that is also meaning not the bases. It's kind of nice in this case, because that means I don't actually need to bother finding the area of these hexagons. I don't need that formula we talked about in the last chapter at this time. I probably will later, but right now I'm all right. So we are thinking then about our formula, lateral area is equal to the perimeter times our height. So again, our height, that's the length of the altitude, which is also the perpendicular distance between my bases. And I'm given that. I'm given this altitude of 12, or this altitude here, which has a measure of 12, so height is 12. My perimeter, that's going to be my side length of 5, but then times 6, because I've got 6 congruent sides in a regular hexagon. That term regular is important to know here. So we'll have 5, the side length, times 6 for 6 sides. So our lateral area will be equal to 5 times 6 times 12. Or let's see, 30 times 12, and let's see, that actually comes out to kind of a nice even 360 square centimeters. Okay, let's talk about surface area. So this is just lateral area, where we're just, again, looking at the lateral faces and the area of those. Surface area is going to be similar, but this time we're going to add in those bases. So we often refer to the surface area as S. You can see that there. And when we're talking about a right prism, then the surface area is going to be equal to L. Remember, that was our lateral area, plus 2 times our base. So we've got to find the area of our base, but there are 2 of them, so we have to multiply whatever that is by 2. So we can also represent that like without L necessarily. So you can say that surface area is also just equal to the perimeter times the height plus 2 times the area of the base. Okay, so let's jump into another example where we're this time finding the surface area, so including the base this time, of our rectangular prism. So again, this means the base is a rectangle. When that's the case, we can almost pick like any of these faces to be our base, but maybe just because it seems a little obvious, I'll say that the side that the figure is actually like resting on is our base. So of course that means right across we have the same congruent base up here. So what is the area of our base? Well, it's a rectangle, so we're just looking at length times width. And our length times width, we're given 6 for perhaps our length and 12 for our width. So we'll say 6 times 12. And that, of course, is just going to be equal to 72. Let's see. Yep, there we go. Okay, so we'll need to multiply that by 2. So we'll think about that. 72 times 2. We'll write it that way. And I also need to figure out my lateral area. So my lateral area, again, that's my perimeter times the height. So based on what we've decided our base is in this figure, our perimeter then is going to be 6 plus 12 plus another 6 here plus another 12 there. So the perimeter, perhaps I'll write that as 2 times 6 plus 2 times 12. And then our height then is this other dimension that we haven't talked about yet, this other 6. So our height will be 6. All of that together, let's see, is going to get me to 24 times 12, I believe. Let's see. Just kind of simplifying there. So if we add all of this up, our 2 bases and our lateral area, we'll get, oh, interesting, 360 square centimeters again. Just like before. It's not exactly, a pattern to notice and use later, but interesting as it is. Okay, let's do another quick example. This time we're looking at a triangular prism. So again, base is a triangle. I want to point out, it's really, really tempting for us to look at a shape like this and say, okay, this surface where my figure is kind of resting on, like the bottom of my surface, that is the base. That's not true, especially when we're talking about prisms. So we're given this is a triangular prism. We need 2 congruent polygons for our bases. So that means our triangles are the 2 bases. So if I'm finding the surface area, remember the surface area is equal to our lateral area plus 2 times the area of our bases. And of course the lateral area is our perimeter times our height. So I don't quite have all of the necessary information, it looks like, in order to find like the perimeter or determine the rest of this. So I want to think about finding some missing pieces here. I'm going to need to figure out what is this length, what is this length, and then I'll be able to determine the perimeter. Now the area of my bases, we'll do that afterwards, but that won't be too complicated. We'll just need to use the area of our triangle formula. Okay, so let's go ahead and call this an isosceles triangle. So I'm going to say these two sides are congruent, and I'm going to label them X. So let's call that X. Now, when we have an isosceles triangle with the height drawn, we also know that that height or that altitude bisects the opposite side. So if that's true, then each of these little segments is going to be 6. And I can solve for then X by using the Pythagorean theorem. I've got this little right triangle that's half of our base, where X is the hypotenuse, 8 is one of our legs, and 6 is one of the others. So let's see, if we solve this using the Pythagorean theorem, perhaps I'll set up 6 squared plus 8 squared is equal to x squared. So we'll have 36 plus 64 is equal to x squared. 36 plus 64, that's just 100. So if we take the square root of 100, of course, we'll find x is just 10. So we can perhaps relabel our triangle here. So our triangle has the dimensions of 10, 10, and 12, meaning I can find now the lateral area. The lateral area, let's say our perimeter then is 10 plus 12. Now let's see, what is our height? Our height is the distance between our bases. We're given that is 10. So that formula could represent our lateral area. That's going to simplify to what, 32 times 10, or 320. Okay, so we've got to add in then our bases. So let's think about what are the bases. Well, remember that our area of a triangle is just equal to 1/2 times base times height. And we're given both the base and the height. So we're given, perhaps the base we'll call 12 and the height we'll say is 8. Now I have 2 of those, of course, because I've got those 2 bases. So if I plug that into my formula here, 2 times 1/2 times 12 times 8. Our 2 and our 1/2, those are actually going to sort of cancel out. So we really just have 12 times 8 there, which comes out to a 96. Remember, we're adding this stuff together. So 320 plus 96 all together means our surface area is going to be 416. And I'm not really given units, so I'll just call it square units. Okay, so that's some prisms. Let's talk about cylinders. Let's see if I can get to my cylinders page. There we go. All right. So a cylinder is really similar to prism. It's kind of like a circular prism. So the bases are going to be congruent circles rather than any other type of shape. And our lateral face, there's just one of them, is kind of like a rectangle but wrapped up around the circumference of our bases. Now, just as before when we talked about our we talked about our prisms, we can have right and oblique ones. So right is going to be where we've just got this upright kind of image, and oblique is going to be kind of tilted off to the side, similar to like the Tower of Pisa, I guess. So a couple of additional vocab words here. The axis of our cylinder is going to be some segment that has endpoints right at the center of our bases. So it's going to be the line connecting the centers of our bases. We can see this is our axis here. Okay, so in a right cylinder, if the axis also represents the altitude, the perpendicular distance between our bases, then that's what we would define as being right. Otherwise, it's just going to be oblique, which just means it's not right. Right, of course, meaning related to each other with a 90-degree angle. Okay, let's look at then the surface area and the lateral area of cylinders, and maybe the net as well. So here we've got our drawing of our cylinder again, and the net of the cylinder. So you can see we have our two circular bases, and then this whole rectangle. This represents the lateral face, just kind of unraveled, unwrapped from being around the circular bases. So the lateral area of our right cylinder, it's the area of this rectangle only, not the bases. It's just the area of that curved surface that wraps around. So this really is still basically our perimeter times height, but we're talking about a circle, so the perimeter of a circle, we call that specifically the circumference, if I can spit it out. So our circumference, 2 pi r, or pi times the diameter, this looks like 2 pr, there should be a little I in there, or 2 pi r. So we use that instead of perimeter. So for our surface area then, we'll just throw in the area of our two circular bases. So the area of our circles, remember, I think it's a little bit easy to get these two mixed up. The area of our circle is going to be given by pi r squared, as opposed to 2 pi r, which is the circumference. So those are both involved in the surface area formula. So we've got that kind of summarized here. I would recommend adding both of these sort of things into our notes. So for our lateral area, that's going to be our circumference, 2 pi r, times the height of our cylinder. The surface area will be our lateral area plus 2 of our bases, just like we said for our prism. But more specifically, we might add that that's 2 pi r times our height, that's that lateral area again, and then 2 times pi r squared, so 2 of our circles. Okay, well, let's do another example. So we are going to find the lateral area and the surface area of our cylinder. And that's not too bad, because in order to find surface area, we're going to need the lateral area anyhow. We're given the radius here of 12 feet. So that means for my lateral area, remember, I'm looking at 2 pi r times my height, and I'm given my height. 20 feet is my height. So let's plug this stuff in. 2 pi times 12, or we could say that's 24 pi, times 20. Can that go away? There we go, times 20. Or we'll get what, 480 pi? Okay, so we'll probably want to round that off, but maybe for now I'll leave that in terms of pi, just so that we can also get our surface area. So surface area, again, S, is going to be equal to that lateral area, 480 pi, plus 2 times the area of the base. So 2 times the area of the circle, pi r squared. Of course, r is 12. So if we put this all together, then we're going to have, let's see, 480 pi plus 2 times 144 pi. And maybe at this point, I'll go ahead and take my calculator out and round both my lateral area and my surface area off. Maybe I'll just round to the nearest tenth. Or maybe nearest whole number. Yeah, we'll do nearest whole number. So let's see, 480 pi, that's going to come out to about 1,508 square feet is our unit. And then 480 pi plus 2 times 144 pi, that's going to be about 2,413 square feet. Okay, so I would recommend paying attention as you're doing your homework to what you're being asked to round to. I rounded to the nearest foot. I guess it didn't actually say in this problem, but just look for that as you're doing examples. Okay, that is the area, surface area of cylinders and prisms. Thank you.